Hello, welcome back to my channel. Today I'll be going over calorimetry calculations and how to use this equation right here, Q equals MC delta T, or I like to call it Q equals MCAT, on how to solve different problems on how to calculate energy or changes in temperature in different reactions. So I have the variables here listed. That Q stands for heat energy, and that is measured in joules, or capital J. So if you see one of these, that means it's heat energy, described in Q. And then mass is always measured in grams, and that's symbolized as M. C is specific heat, or specific heat capacity. So what specific heat means is basically the amount of energy needed. So based on this unit here, joules per gram degree Celsius. So what this means is that every substance, whether it's water or ice or aluminum or any type of metal, every single substance has a different specific heat or specific heat capacity. So what specific heat means is that how much energy or how much joules is required to raise by 1 degree, 1 gram of that substance by 1 degree higher, so 1 degree Celsius higher. So that's what specific heat means based off of the units. And then you have delta T, which is a change in temperature, and that's your final temperature, or T2, minus your initial temperature, or T1, and that's always measured in degrees Celsius. So here's this first example here. We have a 4-gram sample of glass that was heated from 1 degree Celsius to 41 degrees Celsius, and it was found to absorb 32 joules of energy. What is the specific heat? So, as we're breaking down this question, I know that I am given the grams, or the mass. So my M is 4 grams. And then it is heated from 1 degree Celsius to 41 degrees Celsius. So you have to be very careful here, because delta T can be positive or negative, because it can be heated or it can be cooled. So in this case it is heated, and based off of the T2 minus T1, I know my T1, or my T2 is 41 degrees Celsius since it reaches at 41, and then it started at 1 degree Celsius. So my delta T would be found to be 41 degrees Celsius minus 1 degree Celsius, which is simply 40 degrees Celsius. That is my delta T. And it has a heat energy, or Q, of 32 joules. And it's asking for specific heat. So specific heat is my C value. That is my question mark. So with specific heat, it is either given to you in the question, obviously, like other numbers, or you would have to find it. So using the equation Q equals MCAT, or Q equals MC delta T, we're going to substitute the numbers in. So we have 32 equals 4 times my specific heat, C, times my delta T. And I'm going to use 40 here. And from there, it's just algebra. So to break it down, just to refresh your algebra skills, multiply 4 times 40 to simplify that. So 32 equals, so 4 times 40 is 160 times my C value. And then to find your C equals, you just divide by 160 on both sides. So my specific heat, when you divide 32 divided by 160, you get 0.2. And the units for that is joules per gram degrees Celsius. So what this value tells us is that for 1 gram of glass, it takes 0.2 joules to raise the degree by 1 degree Celsius. Okay? Now I have this example. A piece of lead, and it gives you the specific heat of 0.129 joules per gram degree Celsius, loses 98 joules of heat energy and experiences a decrease in temperature of 29 degrees Celsius. What is the mass of the lead? So to break this down, obviously we have our first value here. My C value, my specific heat, is 0.129 joules per gram degrees Celsius. And then it loses 98 joules. So the key words are very important here. It says loses heat energy. So when energy is being lost, your Q, since we know this is joules, my Q value will have to be negative. It doesn't say negative 98, it says loses 98 joules of heat energy. So my value would have to be negative 98. because the energy goes down. And it experiences a decrease in temperature, so this is another keyword to pay attention to. So even though I'm not given 2 temperatures to solve for, if I'm given 1 temperature, it gives you the decrease in temperature. It already tells you my delta T, my change in temperature, is 29 degrees Celsius. However, the keyword decrease. Decrease means it goes down. So my delta T would have to be negative 29 degrees Celsius. Which makes sense when we do the math eventually, because you're trying to find the mass, right? And then your mass has to be positive. There's no such thing as a negative mass. So since we have these 2 values being negative, when we solve, we end up with a positive number. So when we solve using the Q equals MCAT, we substitute everything in. Negative 98 equals my mass, which is my unknown, my C 0.129 times my delta T, negative 29. So again, using your algebra skills, we multiply these 2 numbers together to simplify the equation. So negative 98 equals M times negative 3.741. So these are these 2 numbers multiplied together. Again, it's negative and negative. So what happens when you divide 2 negatives? They become a positive. So we divide on both sides. My mass for my lead will be about, when we round to, let's say, 2 decimal places, to the hundredths place, 26.2 grams. And that is my value for this problem here. Here's this final problem that I want you to try by yourself. Please pause this video and solve it on your own. Do the same breakdown that I showed you here, and pay very close attention with the wording because there are some negatives here. So again, pause the video, solve the problem using the Q equals MCAT equation, and then play once you have your problem solved to check your work. Alright, so this is your final answer. Your Q, or your heat energy, or your energy, same thing, comes out to be negative 121.55 joules. Now the reason why it's negative, because here's the thing, when the keyword, the gold is being cooled from this temperature to this temperature. So my T2 minus T1, my T2, my final temperature for gold is 37, and it started at a higher temperature. So that's why, since it cools down, my delta T would have to be negative. So when you do the math here, all you're doing is multiplying these 3 values, and you end up with the negative answer of negative 121.55 joules. So this sums up my calorimetry calculations tutorial video. So I hope this helps, and thank you for watching.